And so the first problem I told you was f of x equals the square root of x plus 3. So all last class, all of day one, we were really focused on the domain being restricted by having a variable in the denominator, right? But we kept talking about this. Having a square root also restricts the domain if there's a variable underneath of it, because now we have the opportunity of getting an imaginary number, and we can't have an imaginary number. So what do you think I'm going to set up to ensure that x is not going to create a radicand of an imaginary number? Anybody know? So I have to take the radicand, the whole x plus 3, but what must it be? Leo? It has to be less than? Yep, you're right. Very good. So what are we going to do? We're going to take that radicand, right? That expression, because Leo was able to figure this out in his head because he's like, -3 will make it 0. 0 is okay, right? It just can't be any number less than that. But sometimes I'm not going to give you something that's so easily figured out in your head. So we're going to set up an inequality and we're going to say, okay, whatever that radicand is must be greater than, can it be equal to 0? Is that okay? Absolutely. It must be greater than or equal to 0. And now this, if we solve this inequality, then that will tell me all the values that x can be. And whatever it's not, obviously, is part of that restricted domain. So now we're going to do exactly what Leo said. We're going to solve this and we're going to say, okay, well, x is greater than or equal to -3. Is that an acceptable domain? Absolutely. It's saying x must be every number equal to -3 or bigger than -3. So would -3.1 work? Sorry, not -3, -2.9, would that work? Yes. So our domain here is x such that x is greater than or equal to -3. What I just wrote right here, is this set notation or interval notation? Set, perfect. All right, so that was the first part. We were asked to find the domain, but then I also asked to find the zeros. Now remember, when we're finding the zeros of a function, visually, what's happening if we were to graph it? It's where our graph is crossing what? The x-axis. Good. Visually, it's where our graph is crossing the x-axis. And anywhere our graph crosses the x-axis, the y is always what number? 0. So for that reason, we're setting f of x to 0 and solving. So we're going to say x plus 3 equals 0. And now we solve. So when will x plus 3, the square root of x plus 3 equal 0? Well, to solve this, we're going to start by getting rid of the square root. We get rid of the square root by squaring both sides. So now I just have x plus 3 equals 0 squared, which is still 0. And now we solve. X will equal -3. So where will our graph cross the x-axis? It will cross the x-axis when x is -3. Is this an acceptable answer? How do we check to make sure that it's an acceptable answer? We have to make sure it's part of what? The domain. And our domain is saying x is greater than or equal to -3. So is equal to -3 okay? Absolutely. So our 0, if we wanted to write it as a point, would be -3 comma 0. If you just wrote -0 equals -3, I'd accept it. Okay, so that was the first do now problem I asked you to work out. How many people figured that out all by themselves? Okay, I didn't expect you to, but good. All right, next one. Here we're going to have f of x is equal to 1 over the square root of x plus 3. Why do I always start with finding the domain before I find the zeros? Why do I always start with finding the domain before I find the zeros? Violet? Good, because that way we can check for the extraneous solutions to make sure that the zeros are within the domain that we found. So right now, there's actually two strikes against this function. What's the first strike? Amanda? Good, there's a variable in the denominator. What's the second strike? Vivek? There's a radical, there's a square root in the denominator. So right now, because it's a square root, it can't be negative. But because it's in the denominator, it also can't be that denominator also can't be what? 0. So here, when we come to find the restrictions on the domain, I have to take my whole radicand, x plus 3, but now it's not that it should be greater than or equal to 0. It cannot be greater than, it can't be equal to 0. It must only be greater than 0. So then our domain will just be x is greater than negative 3. So if we were to write this domain, it's going to be x such that x is greater than negative 3. Okay, so now for the next part, for the zeros, I take my function, 1 over x plus the square root of x plus 3, set it equal to 0. Now we cross multiply. 1 times 1 is 1. 0 times anything is 0. Is there anything to solve for? No, this is not a true statement. So guess what? There are no zeros. What does that mean if there are no zeros? Ayana? It doesn't cross the x-axis. That's exactly what it means. This does not cross the x-axis. Okay, let me just show you in Desmos real quick. This last one. Yes. Yep. Okay, so there's our graph. If you notice, we're getting really, 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 really close to 0, but are we ever crossing it? We're never crossing that x-axis, never crossing it. All right. So today's lesson. There's some graphs that we're going to be working with quite a bit, and today I want to go over what those parent graphs look like and just how we would shift them. So I'm going to talk about parent graphs first. Okay, so the first parent graph I'm going to talk about is a parabola, and the parent graph is y equals x squared. And now what this parent graph looks like is a smile with the turning point of 0, 0. Now be very careful when you draw this parabola. It should not be like a V. It should all be a smooth curved turn, no V. And now there's going to be some shifting that we can do on this parent graph. And so when we're just sketching and we're doing these shifts, it's never going to be a perfect graph. It's just an idea of where the graph is moving and what it looks like. It will never be perfect because we're sort of estimating everything. But it will be a general idea of where it is and what it looks like. So now the shifting is going to be based on y equals a, open up our parentheses, x minus h, close your parentheses, plus k. And this is going to tell us, if when it's in this format, exactly how to shift it. So what do these represent? I will tell you. For this point in our learning, the A is going to represent whether it opens up or down. Later on, we'll talk about it's actually going to tell us how wide it's actually going to be, the parabola. But for now, it's just whether it's an opening of up or down. So A, if A is positive, open up. If A is negative, open down. Okay, so now we're going to talk about X. Yes, Ariana. Oh, I lost the squared. Sorry, thank you so much. That's so important. The squared should be up here. Now we're going to talk about H. Do you guys see how it's a minus H? This is our standard in our formula. It's X minus H. So when H is positive, it actually is going to be a minus. And when H is negative, what's that going to be? A positive, exactly. So the H is going to tell us our horizontal shift. And then lastly, it's the K. And see how the formula sort of says plus K. So it should be plus. So if K is positive, so if it says plus K, you're going to move up. If it says minus K, then you're going to move down. So this K tells us our vertical shift. So A tells us whether we open up or down. H tells us our horizontal shift. K tells us our vertical shift. And everything we're shifting is this key point right here. That's parent function at 0, 0. So when I say we're shifting, that's what we're shifting. We're shifting that key point. All right, the next thing we're going to talk about, still staying here, is the X and Y Actually, I'll talk about that later. Let's stay with the shifting. So our first parent function is the parabola. The second parent graph is going to be the absolute value of X. And our parent graph for the absolute value of X looks very similar to a parabola, but this time it's a V. It's a very sharp turn. It's not a smooth loop. So for our V, we're still at 0, 0. This is our key point, but it is very sharp. So I'm calling it a key point. You'll also see it be called a vertex, so key point or vertex for these. And guess what's really nice? All the functions I'm showing you today have the same shift pattern. So as long as you memorize that shift pattern for one of them, you'll know the shift pattern for all of them. So now this shift pattern is going to be y is equal to a, absolute value lines, x minus h, close your absolute value lines, plus k. Oh, guys, go back to where it says the horizontal shift. Put a little star here. This only works if x does not have a leading coefficient. And you guys don't have to worry, I won't give you one with a leading coefficient, but we sort of just have to put that disclaimer there. All right, and the third parent graph that we're going to talk about today. So we have the parabola, we have the absolute value v. Now we're going to have the square root, which I call the shooting star. Y equals the square root of x. And that parent graph starts at 0, 0. And it sort of looks like a shooting star over to the right. And what's really nice about this, guess what? The parabola, the V, the shooting star, they all have the same shift pattern. So the shift pattern for the shooting star is going to be y equals a times the square root of x minus h under that square root. And then outside of that square root is the plus k. And this will all make so much more sense to you once we start sketching. Yes. Yep, absolutely. So just to go back down, we have our parabola, we have our absolute value, and we have our shooting star. Okay, before we do the problem, there's just two more things I want to write down. I want to know how to find the x and y intercepts. Okay, so for the x-intercept, what are we going to do? Set y to 0. The y-intercept, any guesses? Set x to 0, exactly. All right, so now you might want to move on to your graph paper because now we're going to start doing some problems where we're sketching. Okay, so for the first one, I want us to sketch f of x is equal to the absolute value of x plus 3 minus 1. And I want you to find domain, range, x-intercept, and y-intercept. I'll let you copy that all down. So before I sketch anything, I'm going to find my domain. I'm going to find my x-intercept, my y-intercept. I won't be able to find my range until I sketch, unless you could visualize it and then you could figure it out before that. But let's go ahead and find our domain. If you guys remember, I said there were only two things that affect our domain. What were the two things that affect our domain? Not Ariana, not Violet, somebody else. What are the two things that affect our domain or restrict our domain, I should say? What are the two things that restrict our domain? Not Vivek, somebody else. Leo. A square root and Lily? A variable in the denominator. Very good. So a variable under a square root and a variable in the denominator. Do we have any of this? A variable in the denominator or a variable in a square root? No. So is our domain restricted here? No. So what did we say? If it's not restricted, it's going to be all real numbers. Perfect. Is it okay if we put the R? Is that acceptable on the test? Absolutely. So our domain is all real numbers. Now, if I asked for this domain in interval notation, how would we write that? Vivek? You got it. All real numbers is actually falls under set notation, so I would accept that. If we wanted to write it a different way in set notation, we could say x such that negative infinity is less than x, which is less than positive infinity. Do you need to know both set and interval notation for the test? Yes. All right, so there's my domain. I said we'd have to come back to the range. So we'll just write range, but then come back to it. Next one, x-intercept. So now for the x-intercept, what do? We take our function, the absolute value of x plus 3 minus 1, and we set y to 0. I don't see a y in my function. So where am I putting 0 instead of what? Lily? Good. Instead of f of x. Isn't f of x and y, aren't they interchangeable? Aren't they the same thing? So I'm going to set it equal to 0 here. So now we have to solve for x. So we're taking this back to algebra 1, solving an absolute value equation. I'm going to add that one over. So now I have x, the absolute value of x plus 3 equals positive 1. Who remembers when we're solving an absolute value equation, once we get the absolute value lines by itself, what must I do now? Ariana? Good. We have to account for when the quantity and the absolute value lines are both positive and negative. So we set up those two different equations. So we're going to say x equals negative 2 and x equals negative 4. So if I wanted to write these x-intercepts as points, the point for these x-intercepts will be negative 2, 0. That's one point. What's the other point? Negative 4, 0. Those are our x-intercepts. Okay, so now we found the domain. We found our x-intercept. Now we want to do the y-intercept. So we're going to say y is equal to the absolute value of x plus 3 minus 1. Anish, what's the problem? Huh? Oh, did you need a plug or something? No, you just moved yourself? Okay, so now for the y-intercept, what do? We let x be what? 0. So let x equal 0. So we're going to have y equals the absolute value of 0 plus 3 minus 1. So y is going to equal the absolute value of 0 plus 3 is 3. And the absolute value of 3 is just 3. So now we're going to have a y-intercept of 2. How do I write that as a point? 0, 2. Perfect. There's my y-intercept. Okay, so now I've answered all of my subcategories except for the range. We'll come back and answer that later. Now I want to graph or sketch. It's not really an accurate graph, it's more of a sketch. So when I sketch this, I have to remember what the parent graph looks like. And who remembers what those absolute value lines parent graph looks like? Yep, a sharp V, perfect. So it looks something like this. But now it's saying I have shifted. So remember, it's y equals a times the absolute value of x minus h plus k. So this is y equals the absolute value of x plus 3 minus 1. So now what am I shifting here? I'm shifting my vertex, this sort of key point here, the only one I plotted. This is what I'm shifting. So now it says it should be x minus h, but it really is x, but it's written here as x plus 3. So what does that h mean? I'm going to shift 3 units where? Because it's supposed to be a minus, but it's a plus, we're going left. Exactly. Because it's the opposite of what it's supposed to be. So we're shifting 3 units left. And what about the k? I'm going to shift 1 unit down. Anybody confused with why I'm going left and down? So what point am I moving 3 left and 1 down? Violet. The vertex. Excellent. So now we're going to go and sketch this. And so my vertex was originally on my parent graph 0, 0. But because of the shifting, we are now going 3 left, 1, 2, 3, and 1 unit down. This is my new vertex. I'm not sketching yet. I just moved my vertex. Now I need to plot the other points that I got. What were the other points that I got? Well, I got 2 x-intercepts. I had 1 x-intercept at -2. And I had another x-intercept at -4. And I had a y-intercept at +2. So now we sketch this. And we know it looks like a V. So this is my sketch. My V is not the best, but it should be a V. Just steady your hand, it'd be better. Do I need my arrows at the end of this V? Absolutely, because it shows it goes on forever. So now I just want to double check. I said my domain were the infinities. Does that match up with my graph? Is the domain the infinities? We didn't find the range because I didn't know the range until I sketched it. So what's my lowest point here in this graph? Amanda? -1. Is it included? Yeah, so I'm going to do square bracket -1. And do we agree our highest points are the infinities? We're going up forever. All right, this is where we stop. No homework today because I didn't finish the lesson. Happy weekend.